Uh, in this session of simulation of binary system acetone plus methanol, let us look at the VLE behavior of the system. Okay. As it is, if I try to draw VLE, that means TXY diagram at fixing the pressure constant. Suppose a pressure is fixed as 1 atmosphere or whatever unit consistency we take, and suppose say I'm going to draw a what you call TXY diagram like this, though it is not thorough straight lines. Please don't. This is for education purpose only. So if I draw a straight line this way, okay. So this particular x-axis is x and y. That means mole fraction of the more volatile component in liquid as well as vapor phase. This ranges from 0 to 1, and this is temperature in degree centigrade. If this is so, then how does our curve look like? This is the boiling point of one component. Suppose say more volatile component. Yeah, so we should start here. So more volatile component will be here, less volatile component will be here. The curve something looks like this. If this is ideal, this particular hysteresis, this particular shape looks this way. That means there is the curve is not like this. Suppose say if it is a minimum boiling azeotrope, this looks like this. If it is a maximum boiling azeotrope, it may look like this. Okay, that means if there is an azeotrope formation, the curve is not as smooth as drawn in the what you call box. Okay, so this particular what you call portion here, this is at this place, that means this place, this is pure component A. In our case, it would have been acetone if it is ideal. This is the temperature of the pure component B. Okay, but this case is only when the system is behaving ideal. Okay, so if I say this is 60% feed composition, then this is boiling bubble point and this is dew point. So in between these two, there is a two phase. So this is L plus V, this is liquid, and this is vapor. So this is this particular portion. That means where we are seeing, suppose let me take another, yeah. This particular portion is bubble point temperature. And this particular portion is dew point temperature. So this is the behavior of a system if the components which we have chosen, the mixture in which the components are chosen, the mixture is behaving ideal, then this would be the diagram. But in our case, that means acetone plus methanol, gamma, as it is, we know it is greater than 1, so it is forming azeotrope. Okay. Definitely there is azeotrope. Theoretically, what does azeotrope means? See, relative volatility, it lies between 1 and somewhere 0. Okay. Suppose say, yeah, so let me not confuse you much here, but let me, there is a concept of alpha, relative volatility. If it is much, much greater than 1, then separation is more, or the distance between these two curves is more. Okay, that is the reason I have shown you that. Alpha is equal to 1 means azeotrope. Previously, what I have given 0 to 1, it is not, it is wrong. Alpha, suppose say at this position, alpha is suppose say 0.7. At this position, alpha is suppose say 1.9. That means in between these two, there is 1. in between these two, alpha 0.7 at x is equal to 0, alpha 1.9 at x is equal to 1. That means in between alphas of 0.7 to 1.9, there lies alpha as 1. 1 means there is an azeotrope. Okay. Now, let us come back to our simulation part and then try to plot the VLE diagram for acetone methanol system using Wilson equation as the equation of state. See, again, selection of the Wilson equation is also another important topic. Now, what are we having here? So, in this condition, we are having, acetone. Let me choose this as component 1 and methanol as component 2. Okay. Now, I'll go to, where should I go? I go to utilities and sorry. So, I have taken something else. I come back to flow sheet. I go to utilities. I add now here material streams or phase envelope or binary phase envelope. We will check here. Phase envelope, if I say feed acetone, let me check whether it is possible here or not. Now see, this is y-axis and x-axis. So this is phase envelope means it is giving me the other calculations. It is not letting me find Txy, but it is giving me bound point 2 points. So let me erase this out. Come back, utilities, add utility, material streams. Now binary phase envelope. Binary phase. Now here we are having the correct system. Okay, let me undock this so that we find this calculate part here. Now this is the portion what you are seeing. See, compound 1, as I have mentioned here, you can see here, I have mentioned here, compound 1 is this and compound 2 is this. So you can see here, compound 1, compound 2, acetone and methanol. I want to plot, what do I want to plot? I want to plot what you call TXY. Okay, this is the TXY diagram now. Okay, so the TXY diagram options, VLE. And the pressure, you can see the pressure, what is given here? The pressure is given as, taken as, the pressure is chosen here as 1.013 bar. Yeah, so this is the pressure. Okay. Temperature, we are not actually bothered. We leave it as it is. The fraction range is 0 to 1. See, the fraction is minimum is 0, maximum is 1. Step count is saying 40. Step count can be less also, but the curve will not be smooth. Okay. Now the property package is Wilson. Now we are ready to plot TXY. That means pressure is constant. Pressure is 1.013 bar. It is nothing but atmosphere. X-axis basis is what? Mole fraction. See, what is the basis of x-axis? See, x-axis is mole fraction, mass fraction, mole percentage, mass percentage. So let us take mole fraction here. And then now you come here and then press calculate. So it is calculating here, see. It is calculating here. Now we got the, what you call, curve of TXY diagram. So we got TXY diagram here. The TXY diagram, something is shown here. Okay. There is an azeotrope here. We can see here. It is actually overlapping here and then forming. So if I say, if I increase this, oh, yeah. Okay. Let me plot it again. Let me plot it again so that, yeah. Zoom out. Okay. Let us go to zoom out. So where will be zoom out? It will be in view. Let's go to view somewhere. Okay. And then, okay, one second. So in this only, let us see. Yeah. So I think now, yeah, somewhere, yeah, okay, okay. Unzoom. Unzoom all pane. Now see, this is the curve we are getting for the T versus XY. Mole fraction of acetone. See why it is giving us acetone? We said, no, it is more volatile component as we are considering. So now this part, you know, this portion, this curve, which is brown or red color, is bubble point curve, and this is dew point curve. We can actually change the thermodynamic system and also check how it is behaving. So we can compare this, what do you call, what do you call, this is the table what we can obtain, and we can see come down, it's a 40, around, somewhere around, what is the curve? Curve is around 0.72 something. So let us go there. See, here 0.7, x is 0.7, and we will have similarly y also. So this is temperature, x and x, okay? So like that we have, so this is x and temperature. Okay, this is how it is. So here somewhere the temperature will be same at one particular point. Experimental data, we don't have any experimental data. If we have experimental data, we can actually do some regression analysis. Okay. Okay, we'll come back to another session later.